my name is Meg O'Hearn, and today I'm going to be talking about the ZAPS lab on problem solving. So, this experiment is focused on namely problem solving and also a concept called insight. And to define these, problem solving is when we use available information to achieve a set goal, and we can use this every day for a variety of simple and complex problems, whereas insight is a sudden realization of the answer to a problem. In this specific experiment, we were asked to solve an unfamiliar problem involving a virtual scale and a set of coins. We had to employ different methods to try to come up with the correct answer over a span of different trials. And the predicted results for this experiment were that over the time in the rounds, participants would be better at problem solving and possibly experience sudden insight to the solution. To start this experiment, I was shown a scale and 8 identical coins, and the goal of this task was to find out which one of the coins was lighter than the others by using this scale. So you were told that you had to place equal amounts of coins on each side of the scale, such as putting 2 and 2 or 3 and 3 on each side, and then pressing the check button. Though you had to be careful of how you place the coins because you could only check the scales twice for each round. Then the scale would tip based on the light coin's placement. So if the light coin was not on the scale and still on the tray below, the scale would stay balanced. Whereas if the scale was tipping lower on one side, this meant the lighter coin had to be on the opposite side. So after this, you would press the reset button and then drag the coins off the scale to restart. Then, once you knew which coin was the lighter than the rest, you would drag it into a specific box. If you didn't think you knew, you just had to guess. The independent variable for this experiment was the technique of the amount of coins placed on the scale, whereas the dependent variable would be whether or not the puzzle was solved for that round. For examples, if it was solved in the first round or if it was solved in the second round, so on and so forth. In the graph that was just shown, there's a clear discrepancy between the class data and the reference data. In the reference results, for example, we see that there's just a slight difference between the amount solved in the second and the third rounds, whereas in the class data, it just has 100% solved on the third round and 0% for all other categories. Therefore, I think it's important to note that this data says that there's only a sample size of 1, meaning that my data is the only one being shown at the time. So also, I think it's important to note that when I began the experiment, I had no solid plan for how to find the lightest coin and just wanted to do a random method to get a feel for the experiment. And then for the second trial, I realized the strategy I used could work because it left me a 50-50 chance of guessing the lightest coin at the end. But I didn't guess the 50-50 shot right, so I had to make up another method. And finally, on the final trial, I definitely experienced insight and finally figured out how to do the problem. As I was about to check the scale for the third time using the same method as before, I suddenly realized that if I had just added one more coin to both sides of the scale, I would be able to eliminate an entire side of the scale, which takes away most of the coins. And this makes it a lot easier to narrow it down in less moves. So the results do support the hypothesis that the participants would have a sudden insight into how the puzzle could be solved, and therefore the participants would most likely solve it somewhere around the third or second round and have less participants solving it the first or last round or anywhere after 3 rounds. And as discussed before, the reason for the class results being so extreme is due to my own data being the only one recorded on this table. And these results definitely prove a good test of the underlying theory. This experiment shows how we problem solve and how quickly insight can cause you to know the answer to a problem, even though before it seemed like you have no idea how to do it and you're just guessing. One idea for a future experiment could be to do something similar to this, but instead of finding a later coin, using a sequence of numbers and trying to match up a sequence of numbers. So, for example, you would have a hidden set of numbers such as 7, 3, 8, and then you would have participants guess. And if a participant guessed 1, 2, 3, you would say you have one number correct but in the wrong spot because the 3 is correct but it's not in the third placeholder. So you would see how many times it takes participants to get the right answer and then over different rounds see if they improve and how many trials it takes them.